welcome to the video. In this video we are going to be looking at plotting linear graphs and interpreting linear graphs. But before we do that, for the first task we're going to have a little recap on substitution, because this is linked very closely into what we're going to do a little bit later in the video with plotting linear graphs. Okay, so if I give you an expression 3x plus 1, and I told you that the value of x in the expression was 3, we would substitute the 3 where the x is. 3 times 3 would be 9, then we would add on the 1. So if I told you that x was 3, we could say that the full value of this expression was 10. If I changed the question and I now said the value of x was 1, I would take the 1, substitute it into the expression. 3 times 1 plus 1 is going to tell me there's a value of 4. So little recap there, that when we've got a number and a letter next to each other in algebra, it does mean multiply, which is why at this point I've wrote it as 3 times x, which becomes 3 times 1 when I do the substitution. If I changed the question again and said x now has a value of -2, I would take the -2, substitute it into the expression. 3 times -2 is -6. Add on the 1, I come 1 closer to 0, so I'm going to end up with a value of -5. So a little recap on substitution there. Let's have a go at one other expression. This time I have an expression of 2x minus 1. If I tell you the value of x is 3, I'm going to take the 3, substitute it into the expression. 2 times 3 would be 6. Then I take off the 1. It's going to leave me with a value of 5. So when x is 3 and I substitute it into this expression, my outcome, my result, is 5. If I was to say that the value of x is 1, I take 1, substitute it into this expression. 2 times 1 is 2. Take away the 1, it's going to give me a value of 1. Again, 2x is equivalent to 2 times x, which once I do the substitution becomes 2 times 1. If I make the value of x a negative, -2, substitute that into the expression here. 2 times -2 is -4. Then I'm going to subtract 1, so I get further away from 0. That's going to take me to a value of -5. Okay, first task for you to do. You have the ability to pause the video at this point. For the red questions, could you substitute x, in x being 2, into each expression? For the ambers, could you substitute x is 3 into all 4 expressions? And for the green, the slightly harder questions, I've used a negative value. Could you substitute x being -2 into these expressions? Could you show me some full working out and show me the substitution that you've carried out? Could you pause the video now and have a go at these questions? Okay, welcome back. I'll show you my solutions. They look like that. So for each expression, I've took the value of x, substituted it into an expression to get my value. I've took x being -2, substituted it into the first expression, calculated the expression. There's my answer, -5. Could you mark up your answers? If you've made any mistakes, could you make a few corrections? If you're struggling with it at this stage, just rewind the video. Have a little look through my explanation on the first 2 slides. Okay, this leads us nicely into today's topic of plotting graphs and plotting linear graphs. Okay, so what you should notice is this bit here, after the y equals, is very similar to expressions we have just been substituting into. Okay, and we're going to use the process of substitution to find a table of coordinates to help us plot our linear graph. So for example, I'm going to take some values of x. I've decided to use between -3 and 2, just because they would fit nicely onto my axes here. So I'm going to take x being -3, I'm going to substitute it into here. 2 times -3 is -6. Add on the 1, that's going to give me a y value of -5. So I'm doing a very similar substitution process to what I did on the first two slides. Now I take -2, substitute it into the expression. 2 times -2 is -4. Add on the 1, -3. Then I work my way through the table, substituting in each number individually, coming up with some y values. Each of these now is going to represent a coordinate which lands on the line y equals 2x plus 1. A couple of things to talk about at this point. If you look at my y values, you'll see that they create a pattern, a sequence. -5, -3, -1, 1, 3, and 5. That is increasing by 2 each time. So once we've worked out maybe 3 or 4 of the values, we could predict the remaining values in the table by looking for a relationship or a pattern. That would always be the case when we're dealing with linear graphs, straight line graphs. Another thing to mention is you may have wanted to start from this side of the table when filling in your values. And the reason for that is we're dealing with some positive numbers first, which might just make your calculation that little bit easier and you're less likely to make a mistake. Okay, so I'm now going to plot each of these values as a coordinate. -3, -5. I'm going to put a dot. -2, -3. I'm going to put a dot. -1, -1. 0, 1. 1, 3. And 2, 5. Okay, so you can see that these values create a straight line. For my example, I've made the dots quite big, just so it's very easy for you to see where I'm placing my coordinate. If I was to take my ruler and join those lines up, it would look something like that. So you can see I've plotted each coordinate at its correct coordinate by following the x-axis, then the y-axis, along the corridor, and then up or down the stairs. And then I've joined the first point to the last point using my ruler. This linear graph would continue up and beyond here, and would continue down and beyond here. But for the sake of this lesson, we're just going to look at the values that were given in the table. So I want the graph of y equals 2x plus 1 between the values of -3 and 2, which is exactly what is displayed on the screen here. Okay, one more example from me. So this time, here's my bit of algebra that I'm interested in. That is going to help me find my y values. I'm going to take the value of -3, substitute it into this bit of algebra. 2 times -3 is -6. Then I'm going to take off another 3, which takes me to -9. Then if I substitute -2 in, -2 times 2 is -4. Take away another 3, takes me to -7. Then I go ahead and substitute in the other values. Again, we could have been looking for a pattern. The pattern again is increasing by 2 each time, a consistent amount because we're dealing with a linear graph, a straight line graph. And as I mentioned before, when you come to answer the questions, you may have started with the positive values just to make your substitution that little bit easier. Okay, so now I've completed the table. I've found a set of coordinates that all lie on the line y equals 2x minus 3. I'm going to go ahead and plot those coordinates. I'm going to go along to minus 3 and down to minus 9. You'll notice that the scale on my axes is a little bit different to the previous slide, just because I'm dealing with a -9 here, so we needed slightly more space to include all the values. So the axis itself looks a little bit different, but the process is exactly the same. -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. Again, I've made the points quite big and bulky, so it's quite easy to see the straight line that they are forming. If I was to plot all these values and one of them was a little bit over here or a little bit here, or didn't land on the line, that would suggest I'd made a mistake with my substitution. If I take my ruler and join up my coordinates, they should look something like that. So you can see the small red dots are where I've plotted the coordinates, and I've joined them up with a nice straight line. So what I've shown here is the graph of y equals 2x minus 3 drawn between the values of -3 and 2. Again, this line would continue up here and continue down here, but for the sake of this session, we are just looking between the values in the table, -3 and 2. There's my correct linear graph. I know I've done it correct because it ends up as a nice straight line and all the coordinates land on that line. Okay, now it's your turn to have a go at plotting some linear graphs. So remember, at this point you have the ability to pause the video. For each question, I'd like you to copy out the axes. For each question on this screen, the axis runs from -5 to 5 on the x-axis and -6 to 6 on the y-axis. And for each graph, I'd like you to plot the graph between the values of -3 and 2 for the value of x. So very similar to what I just showed you on the last couple of slides. For each question, could you plot the graph? Could you pause the video now? Okay, welcome back. I'll show you my linear graphs. My solutions look like this. So you can see I've completed the table at the top for each question and then plotted the graph between the x values of -3 and 2. You should know if you've done the question right because you produce a nice straight line going through all the coordinates that you've just plotted. One thing to have a little note at this point is the steepness of the first graph and the third graph. Both of those graphs are a little bit steeper than the graph in the center. I'll be talking about that a little bit later in the video, but just have a think about what you think contributes to the steepness of each graph. Okay, so we have another set of questions to do here. So again, there is 3 linear graphs to draw, 3 straight line graphs using the values of x between -3 and 2. A slightly different axes this time. On the x-axis going from -6 to 6, and on the y-axis from -10 up to 10. For each of these graphs, could you complete the table and plot the linear graph? Could you pause the video now, please? Okay, welcome back again. If I have a little look at my solutions, they should look something like that. So the completed tables are at the top, just take a minute or two to mark up your tables and make sure your graphs look similar to my linear graphs. One thing to notice is on this question here, there's nothing following the x. I just want you to have a think about how you think that corresponds in this graph. What relationship does having nothing here have with the green straight line that we've just drawn here? You may want to have a little think about that before we move on to the next slide. Okay, so what you may have noticed from all the examples in the video so far and the 6 questions you've attempted, each linear graph always takes this form. It's y equals something x plus or minus something. Okay, so I've just highlighted what those values would be. Mathematically speaking, we say y equals mx plus c, when m, the coefficient of x, the number in front of the x, represents the gradient or the slope of a line. So the higher this value is, the greater the slope, the greater the steepness. And the c value, this represents the y-intercept. At what point your linear graph will cross the y-axis. So if I go back to my previous slide, for here, there was no value included, which is why the y-intercept crosses at 0. So I could have wrote this as y equals 3x plus 0, and that would have corresponded to the graph cutting the axes at 0. You can see here the y-intercept is plus 6, which is exactly why this linear graph crosses the y-axis at the value 6. Okay, so this form is what we're going to be interested in for the next few examples and questions. Y equals mx plus c, when m always reflects the gradient and the c value always reflects the y-intercept. Okay, so if I give you an equation of a linear graph, y equals 4x plus 2, and I ask you to find the gradient, which we could call m, and the y-intercept, which we could call c, it's quite straightforward. This is already in the correct order. Y equals mx plus c. The m value is 4, and the c value is plus 2. So what that would look like on a graph is it would look like this. You can see that the plus 2 is shown here, highlighted in yellow. The red linear graph crosses that y-axis at 2. Remember, the y-axis is this vertical axis here. And the gradient is 4. The slope of the line is 4. So what that means is, for every 1 square along, we would go up 4 squares. So the gradient of this line is 4. And what that means in terms of the graph is for every 1 step along, you would be going 4 steps up. So obviously, the bigger this number, the steeper the gradient is going to be. Let's have a look at another one. So if we look at this graph, y equals 2x plus 5. The m is represented by 2, so I'm expecting a gradient of 2. It's not going to be as steep as my previous slide. For every 1 along, I'm going to go 2 squares up. And the y-intercept is at c. So the y-intercept at c would be plus 5, which means that my graph is going to cross the vertical axis at the number 5. So the graph would look like this. So you can see that I cross the y-axis at 5, which is exactly what I would expect from this number 5. And if I took a point on the line and went along 1 square, you can see I go up 2 squares which corresponds to this gradient here. Because this gradient is smaller than the gradient on my previous slide, you should see the steepness of this graph is greater than the steepness or the slope of this graph. Okay, you may want to pause the video at this point and have a go at this question yourself. Could you draw the graph or sketch the graph for y equals 3x plus 4? If you just need a few more examples, don't pause the video at this point and I'll talk through the example. Okay, so we've got y equals mx plus c, with m being 3 and c being plus 4. So my gradient is 3 and my y-intercept is 4. So if I was to look at a graph, you can see here is plus 4 on the vertical axis, on the y-axis. That corresponds to this plus 4 there. And my gradient is 3. If I pick a point on the line, I go along 1 square and I go up 3 squares. So that corresponds to a gradient of 3. Okay, at this point, I would like you to briefly pause the video. You don't need to write anything down. I just want you to look at the graphs and try and match them up with the equation of the linear graph. Could you pause the video now and match up the 3 graphs? Okay, welcome back. So if I quickly talk through this example, I'm looking first of all at this one in the center here. I'm looking for a gradient of 2 and a y-intercept of 3. So if I look at my graphs, this has a y-intercept of 3, as does this have a y-intercept of 3. But if I look at the gradient here, 1 step along would just bring me 1 step up. So I'm going to go back over here, pick a point on the graph, 1 square along, 2 squares up. So this red graph also has a gradient of 2. So this graph here would match up to y equals 2x plus 3. This graph had the other y-intercept at 3, which would match up here. It also had a gradient of 1. Remember, in algebra, if there's nothing in front of the x, it means 1. So if I pick a point on the graph, 1 along, 1 up. So that graph would match up with this equation, which leaves us with this one. Let's just double check. We've got a y-intercept at -3, which is correct. There's -3, and a gradient of -3. So this time we've got a negative gradient, which is why the graph is running downhill. The graph is going down. If I pick a point on the line and go along 1 square, I go down 3 squares before I rejoin the line. So a gradient of -3. Very well done if you were able to match those 3 up without my help. Here's another 3 to have a go at. Could you match up the graph to the equation of the graph? And pause the video now. Okay, welcome back. Let's have a little look at matching these up. First of all, if we look at this first one, a very slight gradient of 1/2, and the y-intercept would be at 0 because there's nothing available here. I could have wrote +0, but there's nothing there, so I'm looking for a y-intercept at 0 at the origin. And if I take a point on the line, go along 1 square, I only go 1/2 a square up, so this graph would correspond to this question. Then if I look at this one here, I'm looking for a y-intercept of +1, which would match up here. This graph also has a gradient of 2, so that works out. I'm looking for a y-intercept of -3, which is correct here, and a gradient of 2, which again matches up here. Pick a point, 1 along, 2 squares up. That would match up with that question. Okay, last task for you to have a go at. So this time I have displayed 6 graphs on the screen. For each graph, I want you to tell me its gradient, followed by its y-intercept, and then put those two values together to give me the full equation of the line. So from the visual graph, I want you to work out its gradient and y-intercept, its m value and its c value, and then put them together in the correct order to give me the equation of each line. Could you pause the video and have a go at finding the equation of each line now? Okay, welcome back. I'm just going to show you my solutions, and my solutions look like so. So for each question, I've highlighted the gradient and the y-intercept, and then placed them in the correct order, y equals mx plus c, to create the equation of the line. On each graph, I've also highlighted the y-intercept and how I found the gradient by counting squares. Okay, if you were able to look at each of those 6 graphs and interpret where the gradient is or what the gradient is and where the y-intercept would be, and take those two values to create the equations, then that is fantastic. You've shown a very good understanding of plotting and interpreting linear graphs.